Ok, pues vamos a comenzar con el evento. Hola, buenos días nuevamente. Mi nombre es Liliana y soy del área de marketing en TradingCAD. Les agradezco su asistencia y su tiempo por estar aquí. Hoy presentaremos el tema de simulación y optimización para el diseño de arneses y piezas flexibles. El día de hoy nos acompaña el ingeniero Moisés Román, del área de ventas en TradingCAD, ingeniero en mecatrónica IPN con posgrados en manufactura, permítanme, en manufactura avanzada, negocios y ventas consultivas, Data Technology a University of Michigan, liderazgo, ITEMS, y con más de 17 años de experiencia en negocios. También por parte de FLEXTRUCTURE nos acompaña Carl Wenger, licenciado en Ciencias de Ingeniería Eléctrica de la Universidad de Kettering, anteriormente Instituto General Motors. Es gerente general de FLEXTRUCTURE Norteamérica con más de 30 años de experiencia en ingeniería de simulación, soporte y ventas. Y asimismo nos acompaña John Lukevich, licenciado en Ingeniería Industrial de Western Michigan University, gerente de herramientas digitales de Sandawar, en Ingeniería y Ergonomía, con más de 7 años de experiencia y con una gran variedad de herramientas de simulación, incluido IPS. Y bueno, pues dejaremos abierta la sección de los comentarios para que nos escriban sus dudas. Si tienen alguna pregunta, con gusto abriremos un micrófono para que participen. A continuación, mi compañero Moisés nos brindará una presentación acerca de nuestra identidad, qué es TradingCAD y las áreas en las que nos especializamos.
¿Qué tal? Buenos días, buenas tardes a todos. Voy a empezar a proyectar mi pantalla. Aquí. Rápidamente una presentación general para que conozcan lo que es TradingCAD y pues realmente, como comentaba Liliana, lo que somos, ¿no? Como ustedes saben, pues TradingCAD es una empresa 100% mexicana que está basada en el Bajío. Sin embargo, pues uno de nuestros objetivos, uno de los principales objetivos que tenemos, pues es brindar soluciones a todos nuestros clientes que les permitan obtener un desarrollo integral en sus procesos, ¿no? Y para esto, pues, estamos o lo complementamos con diferentes estrategias en las cuales desde tecnologías de software, capacitación, validación, y vamos a ver un poquito más de eso. Nosotros cubrimos todo el territorio nacional, tenemos oficinas en cada región de manera local, desde la Ciudad de México, como les comentaba, Irapuato, también en la ciudad de Monterrey, en Hermosillo, y estamos abriendo por la parte del sureste mexicano. Los servicios que ofrecemos. Como saben, pues TradingCAD es especialista en implementación de software de diferentes marcas, tomando desde toda la cobertura desde diseño digital de producto, simulaciones y manufactura digital, también administración de proyectos. Entonces, con todo esto, con diferentes herramientas, podemos darle al cliente un mejor servicio para que atienda mejor sus proyectos. También adicional a esto tenemos servicios de consultoría en ingeniería, con base en ahorita vamos a ver un poquito más detalle de estos, y pues ofrecemos toda la parte de certificaciones y capacitaciones de nuestras diferentes marcas o de las diferentes marcas que somos socios certificados. Somos muy enfocados en, como les comentaba, el diseño digital del producto, en la cual tenemos capacidad de, aparte de ofrecer las herramientas de diseño CAD, en específico de la marca de Dassault Systems, también nosotros podemos proveer servicios de ingeniería y desarrollo de producto, ¿no? ¿Para qué? Pues bueno, para brindarles al cliente un mejor servicio en el cual cuando ustedes tengan un problema con algún detalle, alguna pieza que por cuestiones de dificultad no puedan desarrollarla por la misma naturaleza del proyecto, pues nosotros los podemos apoyar en esa parte. También tenemos diseño de medios de producción, features o herramientas o herramientales, dependiendo de las necesidades que necesiten, ¿no? Perdón, valga la redundancia. Otra parte interesante, y es esto en lo que la verdad estamos enfocándonos ahorita en el mercado, es la simulación. Creemos que el mercado de CAD o las herramientas de CAD ya están muy maduras en el mercado mexicano. Sin embargo, falta dar el siguiente paso hacia los elementos de simulación, ¿no? Es por eso que nosotros estamos muy emocionados de traerles esta marca para todos, para que la conozcan, la de IPS. Ya Carl y John se van a enfocar más en detalle en demostrarles lo que es la herramienta. Sin embargo, pues creemos que es el siguiente nivel o el siguiente paso hacia donde tenemos que ir como industria, ¿no? Como industria local, conocer la parte de diseño y también la parte de simulación. Adicional a esto también tenemos, bueno, son otros más adicionales de simulación que tenemos, otros servicios adicionales. La manufactura digital, ¿no? Como saben, pues también el mercado mexicano se está abriendo mucho en cómo producir o en cómo mejorar los medios de producción. Y pues para esto tenemos que hacer validaciones antes de poner un solo tornillo en una planta, ¿no? Entonces también nosotros podemos ayudar a validar que sus medios de manufactura sean lo más aceptados posibles y cubran con las necesidades que se tengan. Y bueno, por mi parte sería todo. Le voy a pasar los micrófonos a John y a Carl. Ellos van a cambiar un poquito al inglés, ya que pues estamos abriendo esta marca con ustedes, y pues en lo que empezamos a trabajar, ellos nos comentaron que querían dar esta oportunidad de brindarles a ustedes este webinar, ¿no? Entonces voy a cambiar un poquito a inglés. Carl, please, I send you the control for the presentation.
Gracias, Moses. And I will share my...
Si alguien tiene alguna duda o algún comentario, puede escribirlo abajo y ya nosotros lo podemos traducir. O si sienten la confianza de escribirlo en inglés también, no tengan ninguna... adelante, pueden hacerlo.
Okay, thank you. We appreciate the opportunity to present to you today. I'm here with a brief introduction of our company, Flexstructures, and John will present the technology to you very soon. I'm just checking my windows here. So Flexstructures, we were founded in Germany 12 years ago as a high-tech spin-off of the Fraunhofer Gesellschaft, an institute in research institute in Germany. You may or may not have heard of Fraunhofer, but you've heard some music. The MP3 file format, for instance, was created from the mathematical genius of Fraunhofer. So we've been partnered with them many years, and in this case today we're going to discuss the simulation and optimization in real time of flexible cables, which is a very mathematically intense subject. Flexstructures, we are at about 40 people, based mostly in Germany. I represent the business development in North America. We have partners throughout the Far East. And here in North America, we have also partnered with Sandalwood Engineering and Ergonomics, and also now with 3D CAD Mexico to provide sales and support of the IPS product line. Here to introduce Sandalwood Engineering is John Lukowitz. John, can you say a few words?
Yeah, thank you, Carl. Good afternoon, everyone. Lukowitz. I'm the manager for digital tools with Sandalwood Engineering and Ergonomics. So for the last 5 years, we've been partnered with Flexstructures and Carl to bring the IPS technology to North America. So we're going to take you through the IPS suite of flexible simulation tools today. Just a little bit about Sandalwood. We were founded in 1989. We were born out of Ford's Advanced Manufacturing Technology Division, and we continue to work as consultants with a number of large and small manufacturers today. We have offices throughout North America, so in Detroit, Michigan, and Louisville, Kentucky, in Toronto, Canada, and we also have quite a large presence in Mexico with an office in Mexico City. Sandalwood is made up of 3 departments. So we offer a wide variety of services. We have an injury prevention team that focuses on things like ergonomics and safety. We have a systems engineering department. That's my group, doing things like project management, manufacturing engineering, and also working with these advanced simulation tools. And then we have a systems integration team that does plant floor factory information systems, as well as controls engineering. So excited to show you all about IPS cable today.
Great, thank you, John, appreciate that. So over the time that Flexstructures has been active worldwide, we now have over 150 customers, unique customers throughout the world, with over 2/3 of them being from the automotive, transportation, mobility sector. So really a strong concentration in the devices that make us move. So with that, I will I'll mention the background briefly and then turn it to John to give you a demonstration. But really, the value that we are trying to present to you is to move away from to save you as an IPS user time and money that would be invested in expensive physical prototyping. Here is a prototype lab from our customer at BMW, and they have gone away from these 3D models and printed and trying to check the clearances and movement of cables. Their test labs are much more empty now because they have the ability to work with the IPS cable simulation. So 3 years before start of production, they can already determine where the cables are going to lay out, check for bending radii, clearances, motion considerations, so that once you go to production, you have the confidence that this will be a design that can be manufactured, and also have minimized the risk of warranty costs, which is also a consideration. If you are joining us from the automotive industry, you probably already understand that we've gotten much more complex over the last decades in terms of the content of vehicles, both in software and wiring. We now have many vehicles that have 5 or more kilometers of wires within the cars, and looking for ways to reduce cost and weight for that. The major automotive OEMs, both in the US and Germany, are going all in for electric vehicles, for EVs, and the trend is continuing. So the challenge becomes, how do we manage this complex network of communication wires, high voltage power wires? How do we manage the transition to 48 volt systems, which are coming soon as well? The systems have gotten very complex, and together with the work that you may be doing in CATIA, we have with our IPS cable solution where you can save 75% of your design and development time by working with IPS cable simulation. So our webinar today is focused primarily on cable simulation. What in the future, Moises and 3D CAD Mexico, we'd like to continue a series of webinars where we talk about the other solutions in the IPS product portfolio, because we can also assist with assembly path generation, ergonomics and human factors, robotics and virtual paint and sealing, and then have these models available to you in virtual reality as well, so that you can truly understand what your design is capable of in the virtual space, whether it's on the screen or in a virtual environment. So we're going to discuss IPS cable simulation and present that. So what you're seeing here are movies. These are real-time simulations. That is the important math that was developed now 15 years ago and is constantly being improved by the teams in Germany and Sweden developing IPS. It is an engineering accurate solution. We also provide measurement test services so that you can test the bending and torsional stiffnesses of your wires, cables, and harnesses so that you have the confidence, the trust that the simulations that you see are physically accurate and meaningful, and that you can rely on this, because that's ultimately, and in that way, we're doing two things, which is providing you a fast solution and one that's highly accurate. So whether there are small motions of hoses and cables or sensors, or large motions, these type of things move very quickly and can be investigated very thoroughly with IPS cable simulation. So I will stop talking. This is what we're going to see. Please ask questions. We'll monitor the chat window and make the best use of this time. So I will stop. And John, over to you.
Thank you, Carl. Yeah, as Carl said, if there are any questions as we go through this presentation and demonstration, please post them in the chat and we will answer as best as we can. So this is one example of what we can achieve in IPS cable simulation. So we want to, long before start of production, determine the routings of all of our flexible components so that we can analyze them and optimize them to get the best design very early. So we want to understand the behavior of all of the flexibles in our product, how the product is operating or moving, and then we can investigate and change the flexibles to look at things like bending radii or forces within the flexibles or clearance to surrounding components. Whatever the need may be, we can investigate it in IPS. Also, keep in mind, this example we're looking at now is of a piece of construction equipment with lots of hydraulic hoses, but the methodology and the simulation technology works no matter what kind of flexible it is. So whether it's a single wire or a bundle or a multi-branch harness or a preformed coolant tube or a hose or even flexible surfaces like bellows and grommets, we can analyze and optimize them in IPS. So we're going to go through a few examples of this today. Several different ways that we can create these flexibles in IPS, do our analysis and optimization, and ultimately feed that information back into our CAD or PLM systems. So the first way we can do this is with pre-existing 3D geometry. So you can see that I have part of a vehicle here that comes from the CAD system, and we can import this directly into IPS. Regardless of the CAD or PLM system that you're working in, we can import in that data. So we're compatible with a very wide range of 3D formats, including STEP, JT, STL, VRML, and we're also compatible with native CATIA formats like 3D XML, CAT part, CAT product, native NX formats, and native Creo formats. So regardless of what you're using, we can bring the data in. And then in this example, let's say we're interested in the behavior of this brake line here. We want to see how it will behave when the vehicle is in operation. We can simply take this pre-existing 3D geometry and use a tool called the Cable Finder to automatically detect it and make it flexible. So you can see the software has found for me here the center line and the cross section of this brake line. Then we just need to tell the software a little bit about this particular flexible. So what does its cross section look like? And then very importantly, what is its nominal shape? So as I mentioned, we can model any kind of flexible component. So if it's a straight flexible, something that's straight when unloaded, think of just a wire. Of course, we can handle those applications, but we can also handle flexibles with pre-deformation. So if the flexible is pre-bent into some shape before it's installed, we can certainly simulate those kinds of flexibles as well. Next, we need to tell the software just a little bit about this particular flexible. So we have several options here. We can define some basic material properties, just density, Young's modulus, and Poisson ratio. As Carl mentioned, for extremely accurate and in-depth studies, we offer testing services to determine these exact effective mechanical properties. So length density, bending stiffnesses, tensile stiffness, and torsional stiffness. And we can also use one of the flexibles that comes with the library of flexibles that you get with IPS. So in this case, I'll just select this brake hose 10 millimeter and hit OK, and then create cable. And you can see that quickly, I now have this flexible in IPS. As was mentioned, the software is very, very fast and interactive. So we simulate in real time. And as we make changes to the environment or move the flexible, we see that behavior immediately. So it's very, very fast and interactive. Now, obviously, we want to understand how it behaves when the vehicle is in operation. So for that, we will need a motion. We already have a motion loaded in here, so we can see this spindle moving up and down. There are many ways we can get the motion. So we can create it from scratch in IPS. We can also create very complex mechanisms in the IPS tool if we have multiple interdependent joints in the mechanism. But we can also directly import in this motion data from your CAD or PLM system so you don't have to recreate it. And that's what we've done in this case. So now the last thing I need to do is attach my flexible to my vehicle. So that's just a couple quick clicks in here. Oops. Give me just a moment. I attached to the wrong one. There we go. And then we'll just unwind this. So we start with a torsion-free solution. So now our brake line is connected to the vehicle. And if we click play on the motion, we immediately see it moving and we see its behavior in real time. And we can see immediately that there are some problems with this routing and this design, right? Our brake line is far, far too short. And in reality, we would break it and there would be brake fluid all over the place. So this is obviously a problematic design. But beyond just sort of observing how our flexibles look, there are many interesting ways we can analyze their behavior. So first of all, we can create visualizations, basically color maps on the flexible to look at any number of different things. So we can look at stripes to look at torsion, a number of different forces, moments, stresses, as well as the bending radius. So I'll create a color map for the bending radius, and we can customize this color map based on our design requirements. So let's say a bending radius of 25 millimeters is very good in this case, and our minimum is 100 is very good, and 25 is our minimum. We can apply that map and again see those changes in real time. So we can immediately see, we have some problems here. Beyond just visualizing these forces and bending radii and all these different things we may be interested in, we can also create value measurements. So directly measuring different properties of the flexible. So we can look at things like elongation, again, a number of different forces, moments, stresses. I will just create a value measure here for the bending radius. And anything we're measuring will come up in the bottom of the screen and be tracked in real time. So again, as I play through, we can see how that value is changing over the course of the motion. Now, again, we can see there are some problems. And in IPS, we can very quickly, with just a few button clicks, make changes to this design. So we could change the routing, we could change the length, whatever we need to do to make this design comply with our design requirements. So in this case, possibly, adding some length is going to improve that minimum bending radius. And you can see it changing here in the bottom right corner of the screen. That's sort of a manual way to take a look at the behavior, but we also have some very powerful analysis tools. So if I go to my motion, I can analyze over the course of that motion and take a look at how those values change over time. So for instance, if I map my bending radius here, I can create a plot of that bending radius over time to see how it's changing. Just a moment here while it generates the plot for me.
Yeah, and as you were saying, John, it's interesting you're changing the length of the wire in real time as well as the attachment points. So which is really the benefit. You're working with something like you're working with your hands.
Yes, yeah, absolutely. So now we can see how these values are changing over the course of the motion, and we can do lots of interesting things with this analysis tool. So we can drag through to see the behavior at different points in time. We can do things like establish a minimum threshold. So we know our minimum bend radius is 25. We can put that value in here, and the graph will identify for us all the areas where we're violating that requirement. So we can see it's quite a lot that we're falling outside of our design requirements. We can also do things like search for different values. So we can look for global and local maxima and minima or specific values. So in this case, if I search for the global minimum bending radius, I can find that. And this is my worst case scenario over the course of the motion. So we can see the value is about 4.7 millimeters, which is really very terrible. And then we can simply add some length here or change the routing, whatever we need to do to make this design feasible. So I'll just keep increasing the length. I can see my minimum bend radius is changing there in the bottom right corner of the screen. And it looks like at a length of about 220 millimeters, we are above our minimum requirement. So now that we've made these changes, we can simply click this green check mark to save those changes to the simulation, and the updates are done very, very quickly. We can play back through our motion and see the behavior of the flexibles. Again, we're simulating in real time based on the presence of gravity and the material properties that are unique to each of these flexibles. For instance, the wheel speed sensor cable on this side behaves a little differently than our brake line on this side. So this is looking pretty good in terms of the bending radius, but we do have a much longer flexible now. So we may now be concerned with clearance to some of the surrounding components. So maybe I'm worried about the clearance to this trim here. We can also create measurements to measure the minimum clearances between any component IPS. So for instance, I just tell the software what I want to measure from and what I want to measure to, hit OK. And again, anything we're measuring will pop up in the bottom right corner of the screen in real time. So as we play through, we would see the behavior, see how that clearance is also affected. But again, we can create plots of these values. So again, if I just go to my analysis tool, I can create plots of each of these values over time. And we can see how each of them are behaving. So on the bottom is my bending radius. Once again, I'll just search for that minimum value. And I can see my minimum bend radius is 27.5. So I'm doing well there. And let's look for our minimum clearance. And our minimum clearance is about 26.5 millimeters. So I think this is acceptable. And we can, again, just click the green check mark to save those changes to the scene. And you can see how quickly we were able to create, analyze, and optimize this routing in IPS in just a few minutes. Now, what do we do with this information? We've come into the tool. We've done our analysis and optimization. We want to save this information and feed it back so that other designers, other engineers, other people are aware of the changes that we've made. And there are several ways we can do that. We can export out, first of all, just the center line. If I right click on any flexible in the scene, you can see that there's this export center line option. We can also, of course, export out any 3D geometries in the scene. So if I want to just capture the CAD for something, including my flexible, if I just select anything I want to export, I can simply go to File, Export, and export it out in a number of different CAD formats. Again, just about any option you could want is available. And then we can do some other very interesting things to feed this information out. So first of all, we can create motion envelopes. So in other words, we can capture all of the space that this flexible is going to move through while the vehicle is in operation. So to do that, we'll just use the motion volume tool. And all we need to do is tell IPS what we want it to include. So in this case, I'll just include my one segment here. Let me just check my settings, and we'll generate a swept volume for that flexible over the course of the motion. So here's that swept volume. Again, we can export this out in any format you could want. We'll just take a look here. If I make it a little transparent, and I will change the color, we'll see that our flexible is not going to go outside of this volume we've just generated, and we've captured all the design space that it will be moving through. So this can be a great way to allocate design space and let other designers know, don't put any other components in this swept volume. This is the path that we've planned for our flexible to move through. So far, we've been looking at everything in a nominal way, right? So we've been looking at things with nominal length, nominal position and orientation of the fixation points, nominal material properties, but we can also allow anything about our flexibles to vary. So for instance, if we use the tolerance tool, we can create tolerance envelopes for anything in our scene. So as a simple example, we could allow the length of this brake line to vary, let's say plus or minus 10 millimeters. And if we hit generate, the software will generate a volume for us that is takes into account the tolerancing of our flexibles. We can do this with or without a motion, whatever is most useful to the user. We can also allow things like the material properties of the flexible to vary. And again, we can also allow the fixation points to vary. So a very common check that's done is when we align this brake line to this fitting over here, it's possible for the orientation of the fitting to vary a little bit. And we can certainly allow that to vary. In that case, we could do the position or orientation. The orientation about the fitting would be rotation about the z-axis here. And I'll just put in a large value so we can see the difference. If I hit generate, it will do plus or minus 10 millimeters, as well as plus or minus 25 degrees about that fitting. And we can see we get this much larger swept volume that captures all of the space that could be taken if we allow that variance. Are there any questions so far, Carl?
Yeah, yes, we have a couple of questions. The first of all, it's can you check in the chat what happened with multiple wires and the different legs across the section from the same simulations? Another question is, what about the physical laws like gravity?
Yeah. So gravity is taken into account. All we need to do is activate it. So if I go into my settings here, we can just turn the gravity direction to whatever direction is down in our model. So in this case, it'd be -z, and that gravity is taken into account. Again, based on the material properties of these flexibles, how they're routed, where they're fixated, all of that is taken into account in a very physically realistic way. Okay. As it relates to multiple flexibles, there's a lot there. So first of all, we can connect together any flexibles that we need to create like multi-branch harnesses. And we can also take a look at the interactions between flexibles. So for instance, I just made this, this wire here. And if I make a copy of it, I can then activate what's called contact handling between multiple flexibles. So if I tell the software that I want contact between these two, hit apply. Now, if they touch one another, that interaction will also be calculated. So if I pull the end of this one up and move it over here, we'll see them actually pushing on one another. And again, this is all done in real time. You see this very realistic twisting behavior. And then for instance, if we were to pull the ends together, we'll see them have some even more interesting kind of twisting behavior, right? And all of this is taken into account. So obviously, contact between flexibles is not ideal, but there are cases where there may be contact, and we want to take that into account.
John, I think the question was also related to the bundle editor and how we treat, let's say, a harness in which you the individual wires may be made up of different diameters and different properties.
Yes. So a few things on that. We can string together any number of flexibles to make a multi-branch harness. And we can do that similar to how we did the brake line with pre-existing geometry. If you have a model of your harness, we can just take the whole harness, make the whole thing flexible, and attach all these various pieces together. We can also, I'll show you here how we can make a harness from scratch. So if we have some segment of a flexible, and then we want to add a branch into this, all we need to do is tell the software where the branch is going. So in that case, I've just created this little node, which in IPS is a fixation point. And then there's a tool directly in here to create a branch. We just tell the software where along the length of this main segment we want the branch to be. We can drag or define some value, and then we tell it where we want it to go. So in this case, I'm going to have it go to this position here. Let's say this was another connector. And if then I can select which component I would like to use, and we create a branch. And then the interactions between these two branches are taken into account. So if I move one end, we'll see movement in the other piece. If I move this piece, we'll see movement there. So again, this is a fairly simple example of this multi-branch model. But again, you can add as many branches as you need. So if I wanted to create another one, again, I would just tell the software where I need that branch to go, and then create an additional branch. Tell it where that's going, and then tell it which flexible I'd like to use. And in this way, we can string together as many flexibles as we need to get that very realistic behavior of our wire harness. Carl also mentioned bundles. So we can estimate the material properties of each of these bundle components, right? Obviously, they're made up of different combinations of wires, and we want to take that into account so that we get a very physically correct and realistic result. For that, we have a few tools, one of which is the bundle properties estimator, excuse me, where we can tell the software which wires make up this bundle, and it will estimate for us the stiffness values of the overall bundle itself. So if I go in here and I just add in some different wires into my bundle and then hit apply, it shows me an estimated cross section. How big do we think the diameter of this would be? And then it shows me what the material properties of this are. Oops, hold on, where is it? View bundle properties. So we can see this estimation of the diameter, length density, bending stiffnesses, torsional stiffness, and tensile stiffness. And then we can save this back to a library of flexibles that we can continue to use. And if you hit OK, it makes that flexible for you, and you can attach it to your product, use it in the simulations in whatever way you need. I hope that helps a bit with the wire harness and the bundle questions. Were there any additional questions from the team? Okay.
I don't see any right now, so please carry on.
Sure. So in this example, we took a look at how we can make these flexibles, right, from pre-existing geometry, do our analysis and optimization, and then feed that information back into our CAD or PLM system. But we can also create flexibles directly from scratch in IPS. So let me just restart this session and open up another model. Give me just a moment. And we'll take a look at how we can route flexibles from scratch with no other information. So sometimes we may not know what the routing looks like, or maybe we just would prefer to do this work directly in IPS rather than in the CAD system, so that we get the physically correct behavior with the presence of gravity, correct material properties, all of that. So in this case, we'll just go through an example of routing a wire. So you can see we have this engine bay here. And all that we've done in this example as pre-work is define these fixation points. So we've just placed these at each location where we want the wire to run through. So you can see each of these fixation points along the length here. And this is where we want our cable to flow. These are all of the points we want it to go through. So if we know where we want our flexible to go, we can just use a tool called the cable router to tell IPS to automatically find us a way to get from here to here, flowing through all these various fixation points. So all we need to do is select the points that we want the wire to run through, and then use a tool called the cable router to route a flexible between all of those points. So if we look here, the software is giving us a preview with these red arrows and this white line showing us where each of these how the wire is flowing through each of these fixation points. From there, all we need to do is tell the software a couple of things. We can unwind the initial routing. So usually we want to start with a torsion-free solution. So we'll select that option. And then we define a clearance value. So if we know the radius of our routed cable, we would input that here. it's up to that radius, the routed cable would not collide with anything else in the simulation. And then we just hit route cable. And if there is a solution, the software will find it. So this calculation could take anywhere from a second to a couple of minutes, depending on the number of fixation points, how complex the surrounding geometry is, how tight the surrounding clearances are, basically how hard is it for the algorithm to find a solution. But you can see it found this solution very quickly. Again, we would just pick a cable or define the material properties for the cable that we want to route here. And I'll just hit OK. And we have our wire routed just like that in just a few minutes. And now from here, we have the same tool set of analysis and optimization tools available to us. So for instance, we could do a visualization. I'll just do the bending radius. Customize this based on our requirements. So maybe in this case, 100 is good and 20 is our minimum. We can immediately see all of the problem areas along the harness. So it looks like we have an issue here and we have an issue here. Similarly, we can directly measure anything that we're interested in for the flexible. So we can measure, I'll measure the bending radius, and we can see this is the global minimum bending radius along the length of this flexible. And then from there, we can begin to make changes to make our design optimized and make it compliant with what our design requirements are. So again, we can do things like playing with the fixation points. So I have this clip here. Maybe if I try to rotate it some, that looks like that's improving the bending radius in that area. And we're above our minimum in that area. And then we can edit, of course, the length, either the total length of the wire, or we can take a look at the length in each sub-segment. So basically the length between each of these fixation points. And you can see that list here. So I just need to find the correct area that I want to change, which is up here in sub-segment 5. And then again, we can increase or decrease the length or type in some value, and we see that bending radius value changing in real time. So if I go to a length of 130, it looks like I'll be well above my minimum, and I can hit OK to save those changes to the scene. We have the same capability to export out the center line of the flexible, its 3D geometry, anything we see in the scene. And again, we could also use that same tolerancing tool to create a tolerance envelope that allows different things about this flexible to vary. So the same capability, whether it's a motion analysis or a static wire, we can certainly simulate and optimize whatever your flexible needs may be. Any additional questions from the team? Yeah,
John, we can show all different extensions we can import.
Yes, absolutely. I can share a list of them with you if you'd like, but it's extensive, right? So as I mentioned, STEP, JT, VRML, STL, the native CATIA formats, the native NX formats, the native Creo formats. Yeah, there's quite a large table that I can share with you.
Okay, thank you.
Any other questions?
Yes, we can simulate temperature along the wires.
So a couple of things there. There's a few ways we can deal with temperature. The testing services we offer, those testing services can also be done at a given operating temperature or pressure. So that would allow us to understand what the material properties of a flexible are across a wide range of pressures or temperatures. The other way we can do it to get an idea of how the flexibles will behave when they're at a given temperature is, again, to allow that using the tolerancing tool to allow some of these stiffness values to vary. So typically, as something gets warmer, its bending stiffness will be lower. As it gets colder, its bending stiffness would be higher. And one way to look at that is by allowing those bending stiffness values to vary within some range. So for instance, if I activate both of those in my tolerance envelope and hit run, we can see where there's a large effect. And you can see along the length of this, this flexible we just routed, it doesn't make a big difference along most of the length. But in this area here, we do see a bit of a change there, which could affect our clearance values or how the flexible is going to operate when the vehicle is in operation. So that's another way that we can take that into account. But often it is, it's allowing these stiffness values to be different. They will be different at different operating temperatures or pressures, and we can take that into account.
Okay, thank you.
Any other questions from the team?
Si alguien tiene alguna duda o algún comentario, igual siéntese con la libertad de expresarlo, igual lo pueden escribir y pues nosotros trataremos de transmitirlo a John. No sé si alguien más tenga una duda.
Moises, have the questions related to, there were some questions related to CATIA V5 and V6 formats for the electrical harness workbench. Did those get answered adequately?
Oh, yeah.
Okay.
Yeah, I think we'll share the list of compatible
right.
file formats, as well as not just the geometry formats. We'll also share the list of compatible motion formats as well.
Mm-hmm.
Okay.
Okay, yeah. I have another question.
Yeah.
When you import a product, a model, a product, you can maintain the links with the kinematics information, right?
So for that, it depends on the CAD system. So what we will definitely see is the same structure. So however the geometries are structured in the CAD system, that same tree structure will come into IPS. So here you can see, you know, the way this vehicle is broken up into these different groups with other subgroups, that will be maintained. For each CAD system, as far as motion and kinematics go, we have different ways of bringing that motion data in. So for instance, for CATIA V5, we can very easily import in a VFM or a VFZ file, which just brings in the motion, and then we bring in the geometry. And then all we have to do is drag and drop. So you saw at the start of this, this model, our geometry was not linked with the motion, and we would follow the exact same process. We would take that CAD, drag and drop it onto the motion, and just hit OK. And then it will play appropriately. For some other formats, some other CAD systems, we've developed ways to bring the motion data in. And I think we'd be interested to see how you're creating it and how we can bring it in. But in nearly all cases, yes, we can import in the motion.
Okay.
We can also...
Sorry, John, the CAD is V5 or V6?
So for CATIA V5, we can directly import in that VFM VFZ format.
Okay.
For CATIA V6, we've developed a work instruction on how the user can export the motion so we can import into IPS.
Yeah.
So unfortunately, the direct export option for VFM or VFZ was eliminated between CATIA V5 and CATIA V6, but we do have a way, we have a method to bring the motion data over.
Okay, thank you.
Exactly.
We have the other one with CATIA V6. We're using the 3D XML format for the branch.
Are you saying, can we use 3D XML?
Yeah.
Yes. Yep. As of, that's actually quite a new development. As of this year in IPS version 2024 R2, we added the capability to be able to import in 3D XML formats. So we know that that's something that's important to our users, and we just recently added that feature to IPS.
Perfect.
So yes, we can import in 3D XML.
Yeah, I think it's, si alguien tiene otra duda o otro comentario, yes, how to show you how so determine how many cycles the material can fail. Yeah.
Okay, that's a great question. So we do have some tools to look at durability. We cannot yet, this is an ongoing research topic, we cannot yet tell you the exact number of cycles to failure, but what we can do is do a generalized durability analysis for a given routing. And we've used this extensively for some consulting projects, and it works very well for comparing one design to another. So we use a tool, we call it load data analysis. Where is it here? Here we go. If we just right click on a flexible, we see this perform load data analysis option. When I click that, the software automatically does a calculation for me in the background, taking the motion into account, right? So even though nothing is moving here, it's looked at the motion, and it determines this LDA max damage value. We call it pseudo damage. So it's a unitless measurement of how likely the flexible is to be damaged. And it also gives us a color map along the length here. Let me get rid of my, okay, cool. My color map is gone. It also gives us, identifies where the damage is most likely to occur. So in this case, it's right where the flexible is going from this rigid fitting into the more flexible brake line. So that's where the damage is most likely to occur. And we can see based on the color map along the length here, where we're most likely to experience damage. The way that we typically use this is to compare one routing to another. So for instance, if I now take this flexible and I make it longer, or I change the routing in some way, I'll add another 20 millimeters. So 240 instead of 220. And I rerun that LDA, we will see the difference between the two routings, and we can compare between them. So this was the top value here is our LDA, our pseudo damage value at a nominal length of 220. And this is our pseudo damage value at a nominal length of 240. So this tells you that the length at 220 is more likely to fail than the length of 240. And we can use this to analyze different routings, different lengths. Similarly, if I move this, where this fitting is, right? I can move this fitting and the end of my brake line comes along. If I rerun it once again, that will give me another value to compare which is the best. And then from there, we can determine the optimal design that will have the best durability and then go with that routing. And we are hoping in the next few years to have the capability to directly calculate the number of cycles to failure. It's a very tricky mathematical problem, so there is ongoing research in that area, but you can certainly do comparisons between different routings right now.
Yeah. Yeah.
There is one last thing I just wanted to show quickly here, which is our capability as far as simulating flexible surfaces. So we've seen how we can create, wires or hoses or multi-branch wire harnesses. We can also simulate complex flexible surfaces. So things like bellows and grommets. This is just a simple example of a grommet for an air intake. And we can certainly simulate these kinds of flexibles as well, where we see the behavior of that surface, how it's deforming over time. And we have similar capability to measure a number of different things on these surfaces. So we can measure displacement, von Mises stress, the bending radius, curvature, or contact force. And we can also measure those forces. If I turn on the connection points, we can measure the forces on the clamps here. So what we would call a union, where it's actually being fixated. We can calculate reaction forces and moments there as well. So this is a very interesting tool for those who are maybe simulating things that are not a wire, but more of a flexible surface type component. Very, very cool tool that works very well.
Okay. Yeah.
Any other questions?
No. Creo que, no sé si alguien tenga alguna duda adicional. No, I think it's called John.
Okay.
Just what about the tapes?
What's that?
Taping and John.
Yeah. So the way that we simulate flexibles in IPS is we take into account the material properties of a segment or a section of the flexible, right? So we can take the taping or the sheathing into account when defining these material properties. And then in the example of our wire harness that we made over here, we can have different material property values across the length. So if we understand the taping strategy for the flexible, what it looks like, we can either estimate the stiffness values or again, provide direct, exact material properties through physical testing. So there are several options there. I guess the thing to consider is that we're looking at the bundle or the flexible sort of as a whole, which gives us a very quick and accurate result. We're not necessarily calculating what's happening in each individual strand or each individual wire within a bundle. We're looking at the bundle at more of a macro level so we can get that fast and interactive result.
Yes, and in this way, we've also simulated various type of coverings, right, to prevent collision between cable segments, and there's ongoing work to model that. I think, is it worth mentioning some of the clips and connectors that are available in the 3 minutes we have left?
Yeah, absolutely. So we can, let me see if I can add one here. I don't know if I have the database ready, but we can add, we can define or add flexible clips and connectors into a simulation. Basically, you can just right click and add it into some fixation point. And then from there, you can just define any degrees of freedom that you have on the clip or connector. So if it's able to, translate, rotate some amount, we can certainly take that into account so that you get that very realistic simulation of your clips and connectors. So whatever degrees of freedom they have, I don't think I have the clip database loaded here. I do not. Sorry, I wasn't ready for that one. But yeah, we can certainly take those kinds of things into account in the simulation and define whatever the custom properties of your clips or connectors are.
Great.
It got mad at me when I did that, but
yeah. You can pull up a different window.
yeah.
Excellent. Thanks, John.
Yeah.
Yeah.
And we have a question about safety factor value for hose design. And I guess something like a safety factor would be a company internal consideration. So I think that would be design guidance that you would get from your OEM, from your customer. But those type of heuristics, those type of guidelines can be built into IPS as well.
Yeah, if we can figure out what you would like to measure, again, there are many options as far as the analysis. So if we have a way to define the values we're interested in, we should be able to measure them in IPS.
All right, and that takes us through an hour here. That time goes fast.
Yeah.
Thank you very much. Yeah, we need to finish for time for our customers and also for yours, for your time. Thank you, Carl. Thank you, John, for the presentation. Muchísimas gracias por su tiempo, los que pudieron quedarse hasta este punto. Nosotros nos comunicaremos pues, para aclarar todas sus dudas. Entiendo que es muy poquito el espacio de 1 hora para ver la presentación y para precisamente pues, cubrir todas las necesidades. Entonces, pues vamos a tratar de comunicarnos con ustedes puntualmente para conocer sus dudas y qué necesidades tienen y con eso pues ya plasmarlos en la plataforma.